Hi guys, welcome to a brand new episode of PSLE Maths Secrets Revealed. In today's episode, I'm going to show you how to solve pattern questions with the simplest of formulas. So if you'd like to know how to solve a question like this that involves some kind of formula in the fastest possible way, stay with me all the way till the end and I will show you how to decipher questions like this. So if you'd like to know how a question like that can be solved, let's dive in together. And here we go. Gemina uses circles and triangles to form figures that follow a pattern as shown below. So first thing you got to ask yourself is, what kind of question is this? What kind of number pattern are you required to understand? So the common ones that we actually talk about are these things called square numbers. So what exactly are square numbers? Square numbers are like things like, like 1 times 1, 2 times 2, 3 times 3, so on and so forth. Okay, so if you notice that the numbers starts to progress like 1, 4, 9, 16, 25, so on and so forth till 144, we are actually dealing with square numbers. So the second most common number pattern that you will encounter as a primary 6 student in Singapore is actually triangular numbers. So triangular numbers work like this. Like there's a 1, 3, 6, 10, 15, 21. So if you were to actually plot out the diagram for triangular numbers, you realize that they do indeed look like triangles. So another thing that you will take note is that 1, I add 2, it gives me 3, I add 3, gives me 6, plus 4, I get 10, 10 plus 5, 15, 15 plus 6, I get 21, so on and so forth. But today we are not dealing with either square numbers or triangular numbers. The things that we're supposed to do is simply just basically looking out for numbers that we can either multiply or add such that it can get us to the next figure. Alright, so let me talk about the number of triangles that we see. So figures 1, 2, 3, 4 and 5, if you do not really understand how it works, okay, it's actually very simple. So figure number 1, it has 2. Why is it 2? Because 1 times 2 gets me 2. What about 6? For figure 2, 2 times 3, I get 6. For 12, 3 times 4 gets me to a 12. For 20, in figure 4, 4 multiplied by 5 gives me 20. Last but not least, what can go into the box in my table? So for figure 5, it is none other than 5 times 6, which will get me to 30. So 5 times 6 gets me to 30. Alright, next up, number of circles. Okay, number of circles. So if you look carefully, for the number of circles, they are all increasing by 4. Okay, they are increasing by 4. So I notice that 6 plus 4, I get 10. 10 plus 4, I get 14. 14 plus 4, I get 18. So this is the clue for us that when we are trying to find a general formula that works, okay, that actually works for the number of circles, it has to somehow involve multiples of 4. Alright, multiples of 4. So I also realized that, 6, 10, 14 and 18. So how does 6 work? 1 times 4 plus 2 gives me 6. 2 times 4 plus 2 gives me 10. 3 times 4 plus 2 gives me 14. 4 times 4 plus 2 gives me 18. So for the table itself, figure 5, it has got to be 5 times 4 plus 2 to give me 22. Alright, so for figure 5, number of circles is actually 22. We can also keep adding 4, means we add 4 to 18, and this will give us the same result. Alright, so if I added 4 to the 18, it will give us the same result. Okay, what about the total number? Okay, this is very interesting. So why do I say that it's very interesting? Okay, you will actually discover that later. So the total number of triangles and circles, if we actually ask ourselves, if I do not know the number of triangles and circles, right, is there a sort of like a general formula that I can use? The answer is yes. Okay, let me explain how it works. So if I were to add up 30 and 22, it gets me to 52. And I also realize that when it is time for the total number of triangles and circles, interestingly, let's take a look at figure number 5. So for figure number 5, right, it's actually 5 times 10 plus 2. It gives me 52. What about 38 for figure 4? Figure 4, it has got to be 4 times 9, 36 plus 2, I get my 38. What about for figure 3? Figure 3 is actually 3 times 8, 24 plus 2. And that gives me 26. So I realized that the bigger number in the pattern for the total number of triangles and circles, right, is actually 5 more than the starting number. And the starting number somehow is the number for the figure. Alright. So if you still am not very clear, okay, so don't worry. Right now, as I'm trying to solve part B, a figure in the pattern has 240 triangles. What is the figure number? Alright, what is the figure number? So a question like this, right, it has got to do with, I would say, simple trial and error. Okay, simple trial and error. So let's test it out. Our number that we want is 240. So if let's say I try 11 times 12, I know that that is not the answer, because 11 times 12 I'll get 132. What we are aiming for is actually 240. Okay, 240. So the next thing I would like to try is, what about, say, 15 times 16. Okay, 15 multiplied by 16. So once I key this in, lo and behold, this is actually the answer. Wow. So 15 times 16 gets me to 240, and they are asking me for figure number. So figure number in this case has got to be 15. Okay, 15. So figure 15, when it's figure 15, there will be 240 triangles. Alright. As for the total number of triangles and circles, what will it be? Total number in this case, for figure 100, it has got to be 100 multiplied by 105, because the next number that we multiply has got to be bigger by 5 and we plus 2. So 100 times 105 plus 2. What's the answer going to be? It will be 10,502. 10,502. In any case, if we are not able to find the formula for the total, no worries. We can actually use the number of triangles, add the number of circles, and that will also give us the same answer. Okay, like how I did it in the table. Guys, if you enjoyed today's video or you got anything out of it whatsoever, please hit the thumbs up, hit the like button. Also comment below, let us know where you guys are tuning from. That's always good to know. And finally, if you are new to this channel and you haven't already, remember hit the notifications button. That's a little bell sign, by the way, because this year we are committed to making weekly videos to hold you accountable and to make this your best year in mathematics. But for now, this is Teacher Ray signing off. Bye bye.